Hi guys, welcome to Learning Rabbit. In this lecture, which is actually the last lecture of this web application part, we will connect the MySQL database, which we have not created yet, but we will create a Docker container for that, and we will connect it with the REST backend that we created in the last lecture. If you have not seen that yet, I would recommend that you first see that and then come back here on this lecture. So as the name suggests, we are going to connect it with the MySQL in this lecture. We'll first go through the application overview. We'll see what we have to do. We'll see what we have done so far. In the second point, we'll run the MySQL database. So we'll go through the application overview. Then we'll run the MySQL database with some configurations. Then we'll connect the REST backend with the MySQL database, and then we'll test it. So let's see the application overview and see what we have done so far. So we saw that in the last lecture, we created this blue box, which is actually containerizing the REST API. We did this in the last lecture. And now we have to run this in a Docker container. We'll have to run the MySQL in a Docker container. At least for this tutorial, we don't need to do any coding for that. We'll just pull the MySQL database from the Docker registry and run it with some configuration. That's how configurable MySQL image is. Then we'll connect the REST API. We'll change some code here, just 5-10 lines here, and we'll connect this REST API with the MySQL database. And now when we connect from our browser to the REST API, we'll also save some data back in the MySQL. So let's jump right into it and see the code for this. So we'll start by adding some requirements in our requirements.txt because we'll need to do something with the MySQL. So let me add a dependency which is Flask SQL alchemy. Yes. And now we'll add MySQL client, which is also needed. In the Docker file, when we install this, we must also install something else, which is the MySQL driver. So we'll say apt-get install -y default lib mysql client .dev. So we need to install this package as well. So I'm installing this, and there is some change in the base type because the slim version does not have the required environment, because the slim version will not have this package. I tried installing that, but that does not install. So instead of that, we'll use the fat, so when we write Python 3, this is actually a heavier base image. So I'm going to use that this time, which has the necessary package for this deployment. So I'm using Python 3 now so that we can easily install this package, which is required for SQL Alchemy. Now let's go back to our app.py file and start writing some code to connect with the MySQL database. To begin with, we'll have to first import the SQL Alchemy package. So for that, we do this Flask SQL Alchemy. We import SQL Alchemy. So this is what we import, and we'll have to do some configuration for the connection. First, we'll create the database file. So as you all know, the connection string for any database connection starts with a protocol. So the connection string is going to look like this: MySQL. Then we'll have to write the user colon, then the password @host, then we write colon, then we write port, and then we write slash and database name. So I'm going to pick all these things from the environment variables. So when we run our application, I'm going to use the docker run command, and with that I'm going to pass in all these things using the -e variable. So data file is ready. The next step is to add this to our Flask configuration. We have to add this to the Flask configuration, and now we initialize our database object with SQL Alchemy, pass in the Flask object. Now we have to create a model. Model will be persisted as a table. So now let's have an ID column. So that's the column. It should be called ID. It should be type integer. It should be a primary key. Let's it should be of type string, and the tweet that we get back from Twitter. So this is the data. So let's call this as data, and let's call this save it to db data. Let's create a method for it. So the connection string is done. We have created a table, we have saved it to the database, we have called this here, and now what remains is to actually invoke the creation of the table. So create all, and I'm going to just override this for now because we'll run this application multiple times. So I'm just writing it drop also, that it deletes and then creates it again. We have written the table, we have saved the database, and we have initialized the database as well. So let's go to the terminal and see how we can start the MySQL database. I've ran that MySQL image quite a number of times, so I'm just going to autofill that and explain you all the parameters. So you know this already. Minus name is a new thing for you. Minus name is just to specify a container name so that you don't get a big hash. So you don't have to use the big hash for a Docker container. You can just use this name to refer to that container. This is quite helpful when you are running a container. You can just specify minus name and give a name that you can easily remember, unlike the big hash. This is just a port forwarding. MySQL will run inside the Docker container on the 3306 port, and I'm just using that to forward the connections. Then we had the MySQL root password as the environment variable. I've given a password here, root. MySQL database that I want to create is a Twitter. This is the image that I'm using, MySQL 8. MySQL is the image on Docker Hub. 8 is the tag. And this is the command that I want you guys to run, because as you remember, the last thing when you run a Docker run is a command that you run. So the command will be MySQL which will call the MySQL daemon, and this will be the option passed to that daemon, which is just the native password authentication, so that when you log into MySQL, you can just log in using the password. So this is required. So when I run this, so now you see that the MySQL database is running. It is running with all these parameters. So once this goes up, so it says that init process done, ready for startup, and it is ready for connection. You see this. So now let's run our REST backend now as a Docker image. So I'm just going to go in a different folder now. So I'm in a different folder now. Please make sure that you are too. If you want to browse this code, you will find this in the day 7.4, and it is built upon the previous day, which was day 7.3. And this has all the files that we just built, that we just wrote in the PyCharm. So what remains is that you first build this. So I'm going to build it with the name hashtag MySQL. We'll also have to find out the IP address of the MySQL database. So in order to find out the IP address of a container, I've already told you how to inspect a Docker container. Just write Docker inspect and your container name or container ID. When you do this, go on the networks, see the IP address. It is this. So I'm just going to copy that. And just remember this because our REST backend will require this because it needs to connect to the MySQL database. Now let's run this. So I'm just again auto completing all the stuff so that I don't have to write it again. So when you run your REST backend now, again, you know this, you know the port forwarding, and we had a DB host which we use from the environment variable. So you can see that we are using some environment variables: root password, DB host, DB port, DB name. So I am actually using them here while running the application. I am providing them via the docker run command. This is minus e db host, which we found out just now, the db root password, the db name, which was Twitter, the db port is 3306. That's redundant. So, and the Docker image name that we built was hashtag minus MySQL. So when we start this, so now that we have seen the table is already existing here, let's also see the contents of it. Since we have not added anything here, it should be empty. So it is empty. Now let's go to the browser and search for something on Twitter again. And this time, when the query responds with something, we should see something in the database as well. So I'm going to search for COVID again. So you see that the query has committed a response here. Now we should be able to see this in our database as well. So let's go back to the database. Let's see the contents of the tweets table, which were earlier empty. Now it says this. You see that matches is 1. So it is actually persisting the boolean variable as 1 or 0. If it is matched, it is 1, otherwise it's 0. This is an auto increment ID. Query is COVID-19, and this was the response of the tweet. One thing to note here is that you will not be able to exit the MySQL database just by doing a Control-C. You'll have to do a Control plus backslash. I read the MySQL documentation, and there is some a bug, or you may call it a feature, I don't know. But instead of sig term, this is one sig term. This is when you do a control C, the signal of termination goes. But what they have done is, I think they have used sig quit. So that requires a control plus backslash and not control plus C. So make sure that you use control plus backslash to kill the MySQL container. Let's go back to our slides. So we have done this part. We have been able to connect the backend with the database on this port, and we have also connected the front end with the REST API over port 5000. Let's see what all problems we faced during the creation of this web application. So on the left side in the red box, I have the problems, and on the right, I have some solutions for it. So the IP address was hard-coded, and what if the address changed the next time MySQL comes up? For that, we will use the Docker service discovery. That is the solution I'm providing you guys. So for that, we'll use the Docker service discovery in the later lectures. Service discovery, in a layman term, is just a way for Docker to give you a connection to a Docker container just by using its name. So instead of hard coding the IP address of DB host, you would have just used the name of the container of the database, which was MySQL_DB. So that would have been simpler. You did not have to use the IP address again and again. And just by the name, which will not change, you can just use the name again and again, and you will be able to connect to the Docker. You will be able to connect to that Docker container without hard coding the IP address. So the second point is we have to do a lot of manual work. You saw that I had to build, and then I had to run, and then I had to find the IP address. Then I had to run first the database, find the IP address, and then run my REST. So what if there was an automation around this? There is. There's a way to do all these things with just one command. And we will learn about that in the later lectures as well, which is called Docker Compose. The third point is that the password was given directly on the command line. This can lead to the password leaks. You saw that we gave the root password directly here, which is not a good practice, because when someone goes through your history, he or she will be able to see the root password. So what if there was an alternative for that? The alternative for that is Docker secrets, and we'll talk about that in the later lectures as well. So that's it for this lecture. I hope you learned a lot. I hope now you understand, or at least you gain understanding, how you can create a backend and connect it with the database, both running in separate containers. We'll also talk about Docker networks in the upcoming lectures. So stay tuned, keep learning, give me all the comments you have, do subscribe my channel, do share it with your friends. Keep learning, stay home, stay safe. Till then, it's bye-bye from Learning Rabbit.